So I wanted to call up Preston and Tom. Preston's an engineering director at Google. He's the co-founder and a past general chair of DySPAN. So actually, thank you for making this possible. Yeah, come on up. He's got some thoughts on unlicensed or licensed by rule spectrum. Tom Power is SVP and General Counsel at CTIA. Well, in fact, that a long time ago was the Cellular Telephone Industry Association. Now it's just the Wireless Association. And he might have some thoughts on licensed spectrum. By a coin flip on the 50-yard line, Tom kicks off. And Tom kicks off. You changed the format?
You changed on us.
I know
last night. We changed on
I earned it. So
yes.
Thank you both for coming. Do you need any of this? Need any of this?
No.
Okay, great. Then please come on up, and I'll get out of your way and give you as much time as possible.
So Tom and I decided, with a lot of the 5 minutes extra time, that what we do is really just do more of a fireside, because a lot of the time was taken out. We all prepared a half-hour deck, half an hour deck, and we have no way to get back down to 10 minutes, as Eric
I was afraid
suggested.
if you went first, I would never get it.
And I would consider that an accomplishment. So this is almost a debate between sort of two views of spectrum, between CTIA, and I'm not here representing Google. I'm really here just as a researcher in the field. With a new book coming out, Evolving to 6G, if I can put a plug in, on Amazon on Wednesday. But we thought we'd just sort of have a discussion, then open it up, really, because while we may think of spectrum sharing as a science topic, it is also an incredibly polarizing political topic. It is polarizing economic topic, and so it is contentious. And so this panel, I think, will really focus on not so much the science, but the contention.
And Preston decided we would stand, which I don't know quite what that's about.
Engineers can stand. I don't know about lawyers. I always see you guys sitting.
We're usually down here.
Yeah.
How do you want to start? Go.
So okay, I thought what we do is we'd each talk about some of the key things that we think are important to our perspective on spectrum sharing. And there is a 20-slide deck in Eric's computer, which no one will ever see, apparently. So a couple of the key things. One, in our view, telecom was once a unitary business. It was one guy who did everything. They began your connection, they ended your connection, they did everything in between. It was a national asset. It was absolutely critical to get the resources it got. And of course, that was the AT&T, Lily Tomlin. If you're old enough to remember, had a lot of fun making jokes about its arrogance. What we have today is not that. We have today a business that has devolved to strictly edge access. It constitutes cellular providers that are themselves competitive. But more importantly, 80% of the traffic is not in wireless traffic is not on cellular. It's supported by cable. It's supported by fixed wireless ISPs. So when we look at the edge, what we don't have is that single unitary thing that we need to make sure we resource. We have a set of competitive industries providing edge access. Once you go beyond the edge, we're now in a business where really the telcos have vacated, and it's largely the hyperscalers. So Google, Amazon, Facebook, we have collectively hundreds of thousands of local points of presence where we pick traffic up, typically 5 kilometers from edge users, and get it into the proprietary networks. So telecom is fundamentally different. We can't look and say, this piece of it needs whatever it needs. We have to think about it, how do we keep a balance across all of these modalities? And remember, when we look at all these use cases, if you look at 5G, and I have a couple tables I put in this book. You look at a lot of those 5G use cases that motivated us. A lot of them are indoors. How many of us are going to do AR walking down the street? You probably won't do it twice because you'll be hit by some self-driving Tesla. So these are indoor apps. They're on the Wi-Fi side. They're wireless, but they're not necessarily the same community that supports us outside. So we should be thinking about spectrum policy and thusly sharing. How do we enable all of those guys to compete? There's consumer value in competition. There's consumer value in choice. Now, I do have to do a little bit on CBRS here, because that's kind of my day-to-day job. I had a report card in the briefing you'll never see. Yes, well, we need 2 more guilties during his talk, too. Thank you, Eric. We've been very successful in some of the goals, and I also wrote a kind of a book, because I thought the work that Tom and I did to make spectrum sharing happen when he was in the White House and made CBRS happen had a lot of fairly strong philosophical points that kind of get lost when we get into implementation. So I do have a book, 3-tier shared spectrum. And one of I scored myself against the criteria we had in the book, and we've done we've created diversity. We have over 100 different licensees are operating with protection, whereas in the past we had several cellular providers. We have at least 7 different major use cases in the exact same spectrum. We've had wireless ISPs. Mike Calabrese, who's here, had done a lot of work on anchor institutions. So we really created diversity of use cases, diversity of users. We didn't get the density we want, as he runs political ads and all criticizing. But we did create a lot of trust with DoD. We're entering what I call CBRS 2.0. We got 56 dB of relaxation of some of our interference rules. So for lawyers, that's like, hundreds of thousands. And so by creating that trust, we've started to work it. So I think CBRS will get a lot better. I gave us a C in the report card. With CBRS 2.0, and we solve a lot of these interruption issues. We make private networks possible. So those are some of the thoughts that at least drive ours to think about, not about this user or that user, but what's the health of the wireless ecosystem and all the participants that make it up. Sharing has a place, and I'll even admit exclusive use has a place, maybe a small place, but a place.
Preston and I love to get together and give each other a hard time. We're, I think, closer aligned than some of our own rhetoric.
No.
We met, well, I don't know when we met, but I know we worked a lot together. I was at OSTP, and we were the PCAST, the President's Council of Advisors on Science and Technology, was working on what became their CBRS report, I guess. I remember I used to think about the PCAST, which is this like brilliant collection of business people and academics and others, and then surrounded by supporters like Preston, and I was in the White House more doing administrative support.
No, he wasn't. He was putting the deal together to make spectrum sharing happen.
The PCAST was independent from the White House, so we were not allowed to have editorial input to it, but we could offer technical expertise. And I remember working with this great group of people, and one of the things I thought about the PCAST was, unlike those of us who are sort of in the trenches every day, they don't have to worry about, the niceties of the interagency process or what the Communications Act says about this, or how OMB or is looking at it, or how CBO is going to score the legislation. They can just sort of be out there on a blank slate. The problem is they don't have to worry about any of that stuff. The rest of us do. And so I'm in agreement with Preston that there needs to be room for everybody, but I am here to talk about the need for spectrum auctions and licensed exclusive use spectrum. The FCC's authority to auction spectrum expired a year ago, March. That's a real problem. The designers who perfected spectrum auctions won a Nobel Prize, not because it has raised $230 billion for the Treasury, which it has, but because it's a really efficient way not only to allocate a scarce resource, but to actually drive further investment. Last year, the wireless industry invested $39 billion in CapEx, which is more than most any other industry in the country. And it's all part of a broader cycle of investment that, for us, starts with spectrum auctions. So what do we get out of all this? Well, when it comes to 5G, in the last 2 years, 95% of all new home broadband subscribers have been fixed wireless subscribers. It's an amazing number. It is the most easily accessible data point when it comes to what have been the successes of 5G. One of the challenges is, of course, that it runs over the same network that mobile subscribers use, and so the wireless providers actually have to manage that. if you drew a map, a propagation map from a tower, and you said, look, we can serve whatever 1,000 households in this area, we actually can't, because we got to manage the network so that those home broadband subscribers get robust broadband at home, while also continuing to support the mobile subscribers. So, so there is that capacity constraint. Now, the wireless providers know how to manage it so that you don't notice it, but they do. They can't offer it to as many people as they want to. We did a study that said if we got rid of those capacity constraints, consumers would save $8 billion a year because of the competitive impact of fixed wireless. So just one example, but a really, really consumer-friendly, consumer-enhancing, welfare-enhancing example of why we need more licensed spectrum. There have been 13 countries that have won spectrum auctions since the beginning of 2023. We invented it. It used to be laughed at as a way of allocating spectrum, and then the whole world followed our example. So that's our big push. If you look at the rest of the world, we have fallen behind a lot of our peer countries in Asia and Europe. We did a survey of 5 or 6, both Asian and European countries. We're about 200 megahertz of spectrum behind in terms of allocating mid-band spectrum. We're by 2027, if we don't get our act together, it looks like that'll be more like 500 megahertz behind. If you look at the domestic allocations, unlicensed has 300% more mid-band spectrum than licensed. The government has 600% more. So, and there's no perfect ratio there. It's not necessarily the case they would all have to be equal, but those numbers seem a little out of whack. So we've been pushing really hard for that spectrum. Obviously, the Defense Department occupies a big chunk of it. I can talk about some of the more details of what's going on with DoD and our relationship there, and our efforts historically and continuing to today to work with them. But I don't know if I've said enough for now. And you want to?
We'll kind of let's go back a bit, and then Eric has a mic we'll pass around, so if people want to ask some questions, feel free to go down the center, and you'll interrupt us. 2 comments on what Tom said. Disagree with him. I mean, fixed access, fixed broadband has really become kind of the surprising thing. Now, if you actually look at the revenue on that, it's like a fraction of what they make on handsets. So it's kind of like, well, people really didn't need 5G maybe, and so we got excess capacity, like a fire sale out the back of the store. But 2 comments. One, we should never equate spectrum with capacity in networks. There's this tendency, and everyone does it on both sides, to say I have twice the capacity or demand on my network, so I need twice as much spectrum. Unless you're actually using the entire physical channel for one user. And for multi-systems, in fact, what we're really talking about is how much people spend on infrastructure. Spectrum and infrastructure is completely fungible. You can have lots of radios and a relatively small amount of spectrum. You can have a couple big towers, kind of the prototype of cellular, and use a relatively large amount of spectrum and service a large area. So when we think about spectrum policy, or whether we share or go exclusive, what we're really doing is moving money from one guy's pocket to another. The guy with less spectrum has to build a richer infrastructure. The guy with more spectrum doesn't have to build the same infrastructure. And we can see how this moves, how different users have built different kinds of infrastructure for it. So when we talk about spectrum, it's not really that I have twice as much demand, therefore I need twice as much spectrum. If we did that, everyone's getting the same demand curve. It's really about moving it. If we move spectrum out of, say, unlicensed and move it towards exclusive use, then you move to where we get in Wi-Fi 6E, where you're going to put an access point in every room of your house, and you have to figure out how to pull Ethernet cable there. So we push the cost to the consumer in home. We've reduced the price necessarily for building cellular deployments. So we need to, if we just argue that bandwidth increases, look how much the new Apple 3D thing uses, and so everyone's going to go out and buy one of those. So now I need 20 times more spectrum, so I need 10 gigahertz below 3 gigahertz of spectrum. It's not going to close. So it's really moving things back and forth with density. The second, I do have to take a little shot at Ron Coase, and tomorrow I think his acolyte's here doing the keynote. Isn't Tom Hazlitt doing keynote tomorrow? So you know, since Tom's not on Tom's not on the stage, You know, the argument and Coase made is that spectrum in auctions will find the highest and best use. If you think about that, think about how many people who made buggy whips the horseless carriage came out, decided we should build cars. They did it. Their factories went bankrupt. The innovator's dilemma say people don't see the next opportunity if their current one is working. So one of the concerns I think we have to think about, and I think this is one of the things where sharing has an advantage over exclusive use, is how do we allow technologies to succeed each other, or business models. So if private networks become more important in industry, how does spectrum move around between those to satisfy the demand and keep that balancing going? When we do exclusive use with presumption of renewal, we're essentially saying that business model will be the right business model for perpetuity. Because companies don't. Kodak didn't suddenly see digital was a great thing and we should get making phones. They went out of business. You know, that's the fact of life. People don't find the highest best use. They desperately drag on to hope that next quarter will be better. And so we should be asking the question when we look at these spectrum policies, and I think this is one of the biggest concerns about auctions with perpetual renewal, is how do we reinforce it? Cars, we built them for gas. We're now putting electric cars on the road. Railroads, we went through a long period of time. We've kind of revisited them. They became trails and health walks here if you're around Arlington going out west. So how do we have succession in technology and in spectrum when we exclusively license it to someone with essentially perpetuity? And that was one of the things we tried to get to at PCAST. I think we failed. I think of all the recommendations we had, one of them was Eric Schmidt called it AdWords for spectrum. Well, that didn't happen. FCC said, no, we're going to do 10-year licenses, and they're going to be perpetual. And so I think that's the challenge. I think if you argue for perpetual use, we have to argue about what happens the day when those companies are no longer, every one of us will be irrelevant. What happens to that? How do we turn that resource over and make use of it again?
I'm going to jump in with one comment.
Only one?
Yeah, for now. Would I be more persuasive if I wore a hat, do you think? It works for you, I think.
What?
Anyway, the hat.
Well, that's because I had a hole cut in my head, and it's kind of a distraction.
Well, that explains a few things. Anyway, this relationship between this relationship between infrastructure and spectrum. One of the challenges the wireless providers face in CBRS is these lower power levels. Now, the traditional wireless providers were the biggest auction winners at CBRS. We'll do the best of it that we can, but we're limited to these low power levels, and I just don't understand why we stuck that restriction in mid-band spectrum, where you're wasting the propagation characteristics that you can have much greater geographic coverage. Why not do that experiment up in millimeter wave, where you're going to have less geographic coverage anywhere? And that way, we then get aligned with the rest of the world and what they're doing with spectrum in that range, which then allows you to scale. The equipment vendors can build equipment that works worldwide, makes it cheaper for everyone in the U.S. to deploy the networks, which makes it cheaper for consumers.
So, it's an interesting question. We have a lot of people lobbying in our ear that they would really be very happy if Google would support them on this. So Google doesn't have a position on the high power. But let me talk a little bit of the rationale for the low power. Low power is driving people to build infrastructure. The ultimate goal of our spectrum policy should be to drive people to invest in infrastructure that creates broadband. Spectrum is useless. Radios that create capacity are useful to people. So the argument in the original PCAST that drove towards those numbers was we want a band that encourages people to build dense infrastructure. How many of you in this room are on the Wi-Fi? Hands up. Come on, admit it. Even if you work for an operator, admit it. Come on. Yeah. I mean, most of us, even when we have cellular, go to the dense network because it offers more capacity. And so in CBRS, we wanted a regime that drove people towards building dense networks. Whether I have 10 megahertz in a base station that serves 100 square kilometers, or I have 10 megahertz in a small CBSD that serves one end of a building, I have the same bandwidth. But one of them I can replicate hundreds of times, and one of them exists once. So we wanted a band that drove people towards investing in building infrastructure, not spending $93 billion, roughly like in the C-band auction, where that money doesn't build infrastructure and doesn't serve users. It just gave Congress a pot of money to go spend on things that they didn't have to appropriate. So there's a strong argument here that we want a policy that pushes towards consumer good, and that means encouraging. You can, and Verizon is still built. There's still some operators who have built large deployments, but it really favors the kind of deployment that we've seen with Wi-Fi is really successful in deployments where it's close to people. How do we build a band that encourages what we consider to be virtuous behaviors? Because we can say the government shouldn't encourage one behavior or another, but every regulation in the world encourages a kind of behavior. And so CBRS regs favor build lots of infrastructure, create lots of capacity, and you can't just put up one radio and tie up the spectrum for 100 megahertz. And I will say, by the way, I'm very proud, Tom, despite all your claims about drive tests.
I'm not going to like this.
All your claims on drive tests, that we have lots of coexistence problems. Anti-Clegg spends his life with coexistence. Coexistence means even with low power, we're hitting the capacity of the band. So to my mind, coexistence is good. It means success.
The drive test he's talking about, we drove around some cities and found, I think in Kansas City, 99% of the city was covered by C-band, like 11% by CBRS. Phoenix, it was like 1%. Jackson, Mississippi.
Yeah, I bet if you did.
Jackson, Mississippi, there was no
if
deployments. The cable guys who get behind this aren't deploying it anywhere. In fact, the cable guys say, my point about capacity constraints on fixed wireless, they run ads about it, and they assert that that this is actually impinging it's degrading the product. It's not. It's a theoretical issue that we manage around. But they admit that if we had more capacity, they would be subject to more competition.
Yeah, I'm all for you guys having capacity, build more infrastructure. If you had done that same test at 5.8, I bet you'd say Wi-Fi was empty too. Because by and large, CBRS because it is low power, and it's very tied to anchor institutions, indoor. If you want to see some of the success stories in the private networking area, which is one of the things we really see, is when we auction spectrum, we essentially preclude private networks from it. We sort of see private networks. If you go and Google, please Google, not Bing. If you go Google private networks and you look at all these people who want to sell you market surveys, there'll be $30 billion business there. Clearly, a lot of the use cases that we think about in 5G are ones that enterprises might want to own. They might want to, if they're going to invest, they want to be able to control that investment. I think some people thought 5G slicing and capability exposure would do it. But again, these are kind of precluded when you go into an auction because that spectrum is really taken out. Do I know whether private networks will take off? I don't know. I just wrote a book that's largely based on it. So at least I hope people read the book to find out. But those are the sorts of things we give up when we go in and make life simple for one operator by trading the complexity of many people working together. So yes, we have coexistence problems. I'm proud of it. I wish we had more. But our problem is not lack of density in many cases. It's really, if we put the slides up there, lessons learned. If you do spectrum sharing, make sure you have a rule that someone can solve, mandate solutions to coexistence. So that would have been one of our lessons learned. But yeah, I think it's there. Its density is pretty good. You got some questions?
Yeah, my name is Miguel Gonzalez. I'm a student at the University of Puerto Rico. It's a little bit off topic, but I want to know what's your view on the proliferation of different applications within bands of observation for atmospheric phenomena. For example, in the K-band from 20 to 30 gigahertz, you can still allocate some, have some bands allocated with the FCC, and that collides with the observation of some atmospheric phenomena like water vapor.
Do either of you want to take that?
30 gigahertz, you guys are you have your fingers kind of burned in millimeter wave. You don't want to do that again, do you?
That's not the target.
Yeah, there's a 30 gig right now is a fight with the space guys. And we could get maybe Echoes, if you want to fight, do you think Tom and I go at it, get EchoStar and SpaceX here to talk about that one. But I think, you know, we did an experiment, I think. I think both sides agreed that millimeter wave, the physics kind of works against it. The technology was brilliant that people developed, but the physics is pretty undaunting. My sarcastic comment on that one is if you want to see a Washington street map, look at Verizon's C-band cover, or microwave coverage in DC, because it goes up and down the streets beautifully and disappears. Does that answer your question?
Yeah, very much.
Manisha.
Hi, this is Manisha Ghosh. I'm a professor at the University of Notre Dame. And,
Hi, Manisha. I've never seen you in person before.
really. Thanks for that. I'd like, I mean, I have a lot of comments which I'll keep aside, but a question which I didn't hear being brought up. One of the biggest problems we have. One of the biggest problems we have in this country is with rural connectivity. And I hear how 6G is going to solve rural connectivity where 4G and 5G did not. And I think it's not lack of spectrum that did it, but lack of deployment. So any thoughts about how we actually solve the problem today that vast areas of the country are still not connected with broadband?
You can apologize to your members and then I'll do cleanup.
Yeah, rural is a huge problem, and as you said, it's not a spectrum problem; it's a deployment problem. Interestingly, Congress passed the bipartisan infrastructure law, allocated $42 billion to the BEAD program, and we pointed out that getting fiber to everywhere is awesome; that'd be terrific, but you can't afford it. So fixed wireless could play a big role here. It can be cheaper and faster to deploy, and much more efficient for rural areas. And the administration said, no, we really want to do fiber everywhere. Our position was if a state has enough money to do fiber everywhere, that's great, but the states that don't have enough money to do fiber everywhere don't, as Preston said, pick a technology and say, you really got to go do that to the greatest extent. So to me, that was a big challenge. And the other thing we're running into with these, with the BEAD program is, even if the government subsidizes a big portion of the project, and they don't subsidize all of it, there's a matching in it, you still have to worry about the operating expenses. And so it's just a matter of economics. Obviously, the FCC has run their Universal Service Fund. The Agriculture Department has their subsidy programs. It's a real challenge of the marketplace and the economics of serving those rural areas. But I agree, it's not a spectrum problem.
So in a way, I think it is, because I have to disagree with Tom, because that's sort of the shtick we decided to do. But so one of the problems is if you want to build spectrum, you do exclusive licensing to a cellular company. They look at the world as a cellular problem, and they build cellular, and that's an exclusive license you gave them. I'm very proud in CBRS that we have in the same spectrum Verizon running protected services. And way out in the middle of nowhere, we have WISPs using that same spectrum and doing fixed services because Verizon wasn't interested in that business. I mean, these guys are a unique breed. And someone else is using that same spectrum for a private network inside. So I think one of the reasons why, if we had done our decks, I think the virtues of spectrum sharing is that ability to have these very radically different business models and use cases in the same spectrum. Now, I think to make that work, the spectrum community is hostile to protection or any rights at all. And we end up with these arguments between CTIA wanting all rights and by and large the spectrum community, or the shared spectrum community, not believing in any rights at all. After PCAST came out, like half the people wouldn't speak to me because of our intermediate tier. And so we need to be thinking about these sort of hybrids that allows a Verizon to buy protection so when they invest $1 million in a deployment, it's protected from interference. While that same spectrum is available out in Kansas for doing fixed. So this community needs to come a little more towards the operator perspective. If we want people to invest in infrastructure, we have to protect it. So CBRS has this intermediate tier where you can get protection, but you don't get exclusivity. It solves Verizon's problem that they can invest, because that's our virtue, and it still leaves that spectrum open, because if they haven't invested in it, someone else can use it. I think Mike Calabrese, a long time ago, coined the use it or share it. Well, this sort of implicitly does that. So I think we can do a lot better job on shared. Operators don't want to invest a lot of money in unlicensed because they have no protection. It doesn't encourage the big investments. I think we want his members to be investing in infrastructure. To do that, we need to find this middle ground that lets that rural guy deploy and still makes Verizon safe in its deployment. I think we need to understand more about the dynamics of PALs. We've only done it in this one band in one country. But I think that is the secret to the middle ground between the two of us. I don't know, Tom, you help make it happen. I'm going to make sure if this is reported that Tom is the man who brought spectrum sharing to America.
So here's the thing. I think spectrum sharing is been a totally misunderstood word, and exclusive use is misunderstood. And both sides use these words, but one of the most successful clearing exclusive use auctions was the AWS-3 auction. Well, DoD has plenty of systems still operating in that band, and we just work with them to coordinate around where they work. So it's always sharing. I mean, even if somebody gets, if we have a pie and we each get our own exclusive piece, we're sharing the pie. So it's always sharing. It's just
each little piece is exclusive.
Right.
Yeah.
But we're still sharing the pie. So it's always sharing. And I think we often, and this is more us in the Defense Department, frankly, to kind of talk past each other, because we talk about clearing and they talk about sharing, and then we're a lot. I think we can be a lot closer than it sounds. On the other hand, when DoD looked at the lower 3 gigahertz band that we have some great interest in, they said, no, we can't share.
They screwed us both.
Yeah. I had a whole DoD thing.
Tom Taylor was out, so we can't blame him. So I know, but he was
He's not
out
in
by
DoD
then.
anymore, yeah. I had a whole DoD riff in my 14 slides, but I couldn't get to them because Eric didn't give us enough time.
So, Judy Jan from University of Minnesota. So my question probably not so much about sharing versus exclusive use. I'll touch on the theme you talk about, dense deployment versus kind of more sparse, high-power deployment. A lot of kind of use cases you think about just audio and consumer, if mostly stationary, compared with Wi-Fi, obviously, dense deployment was good, right? But on the other hand, if you think about a lot of future applications, even private 5G RAN, you have to think about mobility. This is where the outdoor usage become important. The problem is you have a lot of dense deployment. You have to do a lot of handover, which actually create a lot of performance issue, right? So in particular, if you have dense deployment just by different private 5G operators, you may not have a coverage. The question becomes, how do you kind of address that problem, especially some applications really need a low latency. I want to actually design my network, for example, using TDD frame structure differently than another one. When you try to share the spectrum, you're going to create a lot of different type of interference. Unless you coordinate all these private 5G operators in an area, you're going to have a lot of problems. I want any thought on that. And also the high power one, for example, I know today using a lot of low band frequency give you a lot of more coverage. So it seems like there's not just exclusive one versus other. Same thing with even the sharing, you need to really have a lot of coordination.
So I'll let Tom have clean up on that one. It's his right this time. So look, if you go look, it's worthwhile if you think about spectrum sharing to go look at the 5G next generation mobile network alliance that kind of laid out. These are what we think the thing should look like, 200 worldwide operators. Look at those use cases. I extracted them in Evolving to 6G book. If you look at those use cases, they're mostly fixed. They're mostly actually indoors. So we've made a migration. We're still looking at the world like the day when BlackBerries were the mobile device. Now they're really untethered devices. They're not really mobile. They're not. We use it on the car. You shouldn't be looking at your phone in the car at all anyway. So, most of these things we're talking about connecting to mobile are assets that don't move that much. They're tethered. They're not plugged in the wall. And so handover is applicable to a handset. It's applicable to my car. But it's not applicable to 99% of the bandwidth I consume. It's my TV sitting there on Wi-Fi connected to stuff. It's the very thing Tom was talking about, all these fixed users that have have a operator hub sitting in there. That's operator hub's not, unless there's an earthquake, that house isn't moving. And so we sort of have this, we have a hammer, so everything looks like a nail. When in fact, we have this really diversity of use cases, which is radically shifting towards untethered, fixed, indoor use cases as the major consumer of bandwidth. If you're thinking about use cases, you need to go look at what did the people who conceived of 5G think they would make money on? Okay, they were completely wrong. They're not making any money. But what they thought they could go at, and I think they were brilliant in what they went after. I thought they were prescient. I just think they missed the point about whether their hammer was the right hammer. So go study it. It's really worth reading those thinking, because I think they're good thinking. And they teach us a lot about what our target is, but it's a different target than what we think of as traditional mobility.
I think to understate, it's a mistake to understate the importance of mobility.
I didn't say it was unimportant. I said it was diminishing percentage.
You said
I was very careful.
You said a minute ago that we spent $93 billion and didn't add any benefit to consumers.
No, I said you
why
didn't
would
make
we
any
spend
money.
why would we spend the $93 billion if it wasn't for consumers? Anyway,
Because T-Mobile had 2.5 gigahertz spectrum.
this is all, we have this academic debate, but it's been 15 months since this country has had spectrum auctions. It is shameful.
And the balance sheets are starting to get healthy again. Time to track them down.
And the fact that we have allowed China and the rest of the world to move forward with very aggressive strategies while we're sitting here just, it's really not great for the country. And maybe 20, 50 years from now, we've got dynamic spectrum sharing and all these other great advances. Hold on.
Yep.
But there's getting between here and there, and the amount of economic benefit and jobs that are created by the $39 billion that our industry invested last year. You can't just you shouldn't just turn off the switch, which is what we've done.
Yeah, I won't argue for what Congress does. But I would point out we have the most unlicensed spectrum with the 1.2 gigahertz and 6 gig, Wi-Fi 6E. So if you think about wireless bandwidth, we are ahead of anyone. We have more accessible wireless bandwidth in the United States for that whole rich ecosystem. Now, if you think of the ecosystem as only being exclusively licensed to 3.5 operators in the United States, then yeah, you see we're behind. If you look at what's available to build a wireless ecosystem where 80% of our bandwidth is, which is indoors, then we are ahead of anyone. It's whether you look at the world through strictly the cellular viewpoint or do you look at wireless as a broader ecosystem. If you look at it as a broader ecosystem, what the FCC did in 1.2 gigahertz is incredible and puts us way ahead. A few people are catching up. But we'll be way ahead of China in available bandwidth for wireless. If you haven't tried Wi-Fi 6E, it makes Ethernet look slow.
You say they're catching up. I think we're looking back, as the unlicensed leader, we're turning around and no one's following us the way they did on license.
Only 500 megahertz. You guys would give anything for 500 megahertz. The worst we're getting, except for China, and you don't want to use them as a role model. Some countries are only doing 500 or 600.
They do a lot of sharing.
Yeah. 500 or 600, just a mere 500 or 600 megahertz.
So we've got one last question, because I'm the bad guy.
Yeah, hey,
This one better be a softball, Mike.
That's a good,
Yeah.
no promises to you. That's a good lead in. Mike Calabrese, a direct wireless feature at New America. I think my name was invoked a couple times
And
here.
you're on a panel later today.
So I feel compelled to, ask a question. And which is, I'm surprised y'all haven't talked about, of course, the consumer infrastructure. Like you say, a little bit more about enterprise and institutional use, because Preston earlier mentioned private networks, and I remember going to Mobile World Congress. 5 years ago, enterprise slicing was all the rage, and back at Mobile World Congress this year, from the main stage, the European CEOs were saying we haven't been able to make this work yet.
Well, no, haven't been able to sell it. They made it work,
Yeah.
just no one buying it.
Well, so a question is, so increasingly when I think, and Preston's written a book on it, on
Thank you
6G
for the
apparently
plug.
now, which I haven't, it's not out yet. But I think of
Wednesday.
network of networks as being a closer approximation of of 6G to anything, but regardless of that, could you talk a bit about like enterprises and institutions, like how they want to use spectrum, particularly what about, what PCAST was about a lot was direct local access to spectrum for enterprise IoT, schools, all this, because, when we see who's using CBRS, like John Deere, Dow Chemical, Port of LA, Chevron, and companies like Chevron are saying, we would never allow like a public mobile network to control, to set up our private, well, we need a private network for security because we customize it, we need to manage it. So anyway, that's a whole space where the sharing versus exclusive, that policy of local access to spectrum seems to be a big deal. So I don't know if you can say more about that.
I mean, you did mention network slicing, and I do think that is one of the ways we solve that problem in terms of being able to have the traditional license provider solve the individual needs of the enterprise. And you're also seeing, oftentimes, even if it isn't the license provider who's has the spectrum, they're hired to help implement the solution. So, yeah, I totally agree. We're evolving, we're progressing. I just feel that we've been a little too quick to dismiss the value, and especially as you see innovations like network slicing that I think can solve the challenge you identify.
So, I got intrigued I got intrigued with this enough so that I wrote this book talking about 6G, and its real argument is to turn 6G towards turn the technology towards private networks, security, open authentication, open up identifier spaces, some of the issues that we've run into in CBRS. Clearly, there isn't an appetite for buying slices. I'm a little surprised. I thought that was the coolest thing since sliced bread. And it uses Kubernetes, which Google believes in. But it hasn't happened. Enterprises really want to own the means of production. As we move from enterprises thinking about wireless services as phones for people to call each other and text, to thinking about it embedded in their machinery and the means of production, they seem to be very, very hesitant on farming that out. I think some of the shutdowns of 2G and 3G have also made them a little cynical about depending on someone else's capital flow. So I think private networks are one of the arguments for this. Right now they're forced to Wi-Fi. We've given them a lot of spectrum. But there's a lot to be said for those bands that they could share and interoperate with mobile operators. And I think that's the hunger we see in CBRS. And I think we just have to wait and see if something happens. But right now, at least, slicing doesn't seem to be the answer that's being adopted. And we see in Germany and in UK, local licensing. I consider it CBRS envy. It's still controlled by regulators because they just can't not control things. But nevertheless, they're still moving in that direction. I think Eric wants to interrupt us.
Eric wants to, yeah, was this okay? And you have the award here for putting up with Eric. I am so happy.
I think I wrote a nasty note at 10 last night.
Yeah,
Thanks,
yeah,
Eric.
really changed it how many times that I changed it?
You don't
It
want
is my fault.
you don't want me to tell them.
No, that's
We'll
right.
keep it a secret.
Anyway, thank you both. As you kind of got the hint, there is the panel today in here, which might be a continuation. No, that's right. It'll be great. And actually, as we were talking about what's going on in the rest of the world, Dave Willis will be here from Ofcom tomorrow morning. Spectrum Week is in here and next door. DySPAN, we're going right behind to Washington Room 1, 2, and 3. Thank you all this morning, and look forward to seeing you later in the week.